I feel like I'm the first year of the pandemic. Yes, you can see it. It's here.
Yep, we can see it.
Okay, okay. Thank you. So thank you, Phoebe. Thank you, everyone. Good afternoon, good morning, wherever you are. Thank you for watching. I am Mahayana. Just a moment, because I had a problem with my screen here. I am Mahayana. I'll be presenting our work I did with Taina today. She was an undergrad student of mine at the time. Now she's doing her master's, and we chose to study the Bouba-Kiki effect in a production task. For those of you who know work on iconicity, you're probably aware of probably familiar with the Bouba-Kiki effect. For those who don't, this is a tendency people who speak different languages have to associate the name Kiki to spiky shapes and the name Bouba to round ones. Not just the name Kiki and Bouba, but actually names with P, T, K, I with spiky shapes and B, M, L, O, U with round ones. Okay. This topic relates to the broader phenomenon of sound symbolism, which is the relation between phonemes and perceptual categories such as size and shape. This has been reported by many experimental studies. For example, the phoneme A evokes the image of something big, evokes the meaning of largeness somehow, and the phoneme E evokes the idea of something tiny, of something small. These associations are believed to play a role in language acquisition, in organizing the lexicon of natural languages, and even they probably played a role in the evolution of language in the human species. In the case of the Bouba-Kiki effect, we can say that this effect is robust across cultures and writing systems. I love this paper because it summarizes everything we have to know about the Bouba-Kiki effect. It doesn't matter if you speak English or Portuguese or Japanese or Quechua or Guarani or any language. If your language has these sounds like P, T, K, you're going to associate it with spiky shapes. If your language has M, B, L, you're going to associate these sounds with round shapes. Most of the results that we know today about this phenomenon, we know that they were obtained mostly with the use of forced choice tasks, in which participants had to decide if nonce words like Kiki or Bouba were better suited for a spiky or a round shape. So they had to assign linguistic stimuli to visual stimuli. This method is valid, of course, it's very useful, but it poses two limitations that we wanted to address in our work. First of all, it overestimates the effect of sound symbolism. We know that if we have more options, if we have Kiki, Bouba, and other nonce words, the effect is smaller. The effect for sound symbolism is smaller. And a second limitation is that researchers get to decide what is a spiky or a round sound. We actually don't know if people would use these sounds if they were to name these pictures by themselves, if they had to choose the name, to create the name. And that's the question for this work. Our question was, what happens when people are free to create whatever name they want for Bouba and Kiki shapes? If participants are not constrained by previously crafted names like Kiki and Bouba, what phonemes, if any, are they going to use to signal a difference between a round and a spiky shape? Are they going to do it or not? We ran a written production task with speakers of Brazilian Portuguese to find out. Participants saw pairs of images like these ones here, one round, one spiky, and they had to write down a name for each one of them. We asked participants to not use existing words or blend of words in Portuguese, so they could not name this image here estrela, which means star, for example. We also asked them to use words that sounded like Portuguese, so this way they would respect the phonological rules of the language. And we chose a written test because it's easier to gather more data this way. It's much easier than having to transcribe later all responses that people would give orally, for example. And it helps that Brazilian Portuguese has a very high spelling to sound transparency. When people write something, most of the time we know the intended pronunciation. We can recover the pronunciation from what they're writing. So we have used this method before in other studies, studies about sound symbolism with Pokemon names here in Brazil. It has been tested. The results are consistent most of the time, all the time actually. So that's why we decided to go for a written task instead of an oral one. These are the stimuli. We collected data from 75 Brazilian Portuguese speakers who named these 6 pairs of stimuli here. Most of them were borrowed from previous studies on the Kiki-Bouba effect. All data was transcribed automatically with a transcription tool that converts text to phonological notation in Brazilian Portuguese with a high level of accuracy. Some data was excluded because they didn't conform to the instructions. I can talk about it later at the Q&A if you want to. At the end, we had a data set with more than 600 names, divided roughly the same for spiky and round names. That's what we had to analyze. So we analyzed our data by grouping consonants in 6 binary categories. We didn't want to go one phoneme at a time. So let's see if people use P for the spike images. No, we decided to group them in using consonants, parameters for consonants. And we used these 3 categories here. So we have all these sounds, all these consonants, Portuguese consonants people used. We can break them into voiceless or voiced regarding their voicing, sonorant or bistrents regarding manner of articulation, and acute and or grave regarding position. This distinction here is not so common, but it shows a difference between sounds that are produced with the tongue as the active articulator or not, okay? After that, for each name, for example, Daledo, the Portuguese pronunciation would be Daledo. Daledo was a word we got, and for each name, a script automatically counted how many vowels or consonants for each sound parameter we had. So for example, here we had 3 voiced, 1 voiceless, 1 sonorant, and so on. I'm not going into much detail about the statistical analysis, but we were interested in the number of segments in a particular category, for example, voiceless consonants. And we tested if this number of segments was changing function of shape, okay? We used generalized linear mixed models, and here I have some results. I am highlighting just the results that were statistically significant, okay? So for looking at the vowels, we found that E was more common in the names of pointy shapes, and the effect was the other way around for U and O. You have this here for E, for O, for U, A and E. We didn't have any difference. For consonants, all the effects for consonants were found in the names of spiky shapes. These names had more chance to have acute consonants, obstruents, and voiceless consonants. So regarding our first question, yes, people use sound symbolism to name round and spiky shapes. But as one reviewer put it, some of these categories are too broad. If you take a look at the obstruents, for example, here we have voiced consonants, voiceless consonants, stops, and fricatives. So what we did was a second round of analysis in which we broke these broad categories down into smaller subsets of consonants based on their place of articulation and voicing. For obstruents, for example, we could break them down into voiced and voiceless fricatives here, voiced and voiceless stops, and we found that only voiceless stops were more common in the name of spiky shapes. We actually don't have a scenario in which all voiceless consonants or all obstruents are more common in the name of spiky shapes, just the small subset of voiceless stops, which, by the way, are the phonemes mostly used in Kiki-Bouba experiments, P, T, and K. Regarding sonorants, we can break them down in lateral, nasal, and in Portuguese, the vibrant R, only this one here. And we found that nasals and laterals were more common in the name of round shapes. So we didn't find initially an association between sonorants and round shapes, like other studies have found with the Bouba-Kiki, the first choice paradigm, but we found it here when we break this broad category in smaller subsets of consonants. So in conclusion, we can say that yes, people use sound symbolism to create new names for roundy and spiky shapes, even when we don't ask them to do it. In our instructions, we didn't tell people, look, you're going to see spiky and round images. It's just like images. These associations are the same that were observed in previous studies that used other experimental paradigms. Although our work doesn't add to the understanding of why we have these associations, why K and spiky shapes, for example, why K, why not M, for example. Our data can attest that these sound symbolic associations are at work when people use language for naming tasks. So a good understanding of language should account for these iconic mappings between sound and meaning. These are some references. Thank you. In case you want to play around with our data set and analysis, you can find everything here on my GitHub.